Hi students, this is the lesson for today for November 19th, and this is about solving one-step equations with rational coefficients in them. So our objectives are one-step equations and writing and solving one-step addition and subtraction equations, and writing and solving one-step multiplication and division problems. So first of all, how do you use one-step equations with rational coefficients to solve problems? So number one-step equations. You can write and solve one-step equations involving whole numbers and negative numbers. So let's look at some examples. So use inverse operations to solve each equation. So remember, inverse is the opposite. So in this one, remember, we want to isolate our variable. So we have z that we want to isolate. And we have 5.2, which is positive. So we need to do the inverse, which would be negative. So we want to subtract 5.2 from both sides, so that gets z by itself, and so then I have negative 9 and subtract 5.2, which would be negative 14.2. And then on b, I have y subtract 3/4 equals 6. So I want to add 3/4 to both sides to get rid of the 3/4 from the y. So that gets y by itself, but then I have 6 plus 3/4, which that's pretty easy. That's 6 3/4. Okay, next I have negative 4c equals 12. So the inverse of these, remember I want to isolate the variable, so I want to get c by itself. So I need to get rid of the negative 4, and the inverse would be to divide both sides by negative 4, which ends up being c equals negative 3. And on this next one, again, I want to get r by itself, and it's division, so I need to get rid of the 3.5, and it's negative 3.5. So with division, the inverse would be multiplication. So I'm going to multiply both sides by negative 3.5, which gets r by itself, and then ends up being negative 25.9. Okay, so some other examples, one-step equations. Negative 7/8 plus t equals 1. So again, I need to get rid of that negative 7/8. So I'm going to add 7/8 to both sides, which ends up being 1 7/8. And on this one, I need to get m by itself. So I need to get rid of the negative 5.2. And it's being divided by it. So I'm going to multiply negative 5.2. And that ends up 18.72. M is 18.72. Okay, so 2, writing and solving one-step addition and subtraction equations. Negative numbers often appear in real-world situations. For example, elevations below sea level are represented by negative numbers. When you increase your elevation, you are moving in a positive direction. When you decrease your elevation, you're moving in a negative direction. So let's look at this example. A scuba diver is exploring at an elevation of 9.5 meters. As the diver rises to the surface, he plans to stop and rest briefly at a reef that has an elevation of 3.2 meters. Find the vertical distance that the diver will travel. So first of all, write an equation. Let x represents the distance that the diver will travel. So we have negative 9.5 plus x is going to equal negative 3.24. So to solve the equation, I want to do the inverse. So I need to get x by itself. So, and I have negative 9.5 by x. So I'm going to add 9.5 to both sides, which ends up being x is 6.26. The diver will travel 6.26 meters. Okay, next. An airplane descends 1.2 miles to an elevation of 3.28 miles. Find the elevation of the plane before its descent. So we write this x, whatever it was, and then it descended 1.2 to end up at 3.28. So again, I need to get x by itself. So I need to do the inverse of negative 1.2. So I'm going to add 1.2 to both sides, which gets x by itself. And then 3.28 plus 1.2 is 4.48. So the elevation of the plane before its descent is 4.48 miles. Okay, 3, temperatures can be both positive and negative, and they can increase or decrease during a given period of time. A decrease in temperature is represented by a negative number. An increase in temperature is represented by a positive number. So after a power failure, the temperature in a freezer increased at an average rate of 1.8 Fahrenheit per hour. The total increase was 12.6 Fahrenheit. Write and solve an equation to find the number of hours until the power was restored. So write the equation, let x represent the number of hours until the power was restored. So I have 1.8x equals 12.6. So this is multiplying, right? So the opposite, the inverse of multiplying is division. So I need to divide both sides by 1.8, which 12.6 divided by, 1.8 divided by 1.8 with the x gets x by itself. And then 12.6 divided by 1.8 is 7. So the power is restored in 7 hours. And let's look at this next one. Between the hours of 9 p.m. and 5 a.m., the temperature decreases an average of 4/5 a degree per hour. How many hours will it take for the temperature to decrease by 4 degrees Fahrenheit? So I have negative 4/5 x equals negative 4. So I need to multiply. To get rid of a fraction with my variable, I have to multiply it by its reciprocal. Then it will cross out. So if you notice, like 4/5, and then I'm going to multiply it by 5/4. So that gets rid of it on that side. And then on the other side, I'm going to also multiply it by its reciprocal, which ends up being 20 over 4, which is 5. So it will take 5 hours for the temperature to decrease by 4 degrees. So we will stop at that for right now. Go ahead and work on the Go formative for today for November 19th. And then if you have any questions, let me know. Thanks.